Question says discuss the continuity of this rational function. You have ln function, you have inverse tangent, and you have x squared minus 1 on the denominator. Let's check the numerator first. On the numerator, you have the following scenario. You have ln of x, which is continuous on 0 to positive infinity. Remember the graph of ln of x? You need to memorize all of these graphs. It's super important. ln of x behaves like this. This is ln of x. So far we know that the domain starts from 0, it doesn't include 0, and goes to positive infinity. Now for inverse tangent. Recall that for function y equals to tangent of x, since it is 1 to 1 on negative pi over 2 and pi over 2, we could define the inverse. The inverse of the function. The inverse as y equals to inverse tangent of x. So remember the graph of tangent. This guy was your tangent of x, negative pi over 2 and pi over 2. And then we define the arctangent this way. So this is inverse tangent of x or arctangent of x, and as you can see, the domain starts from negative infinity to positive infinity, with domain negative infinity to positive infinity. So it includes everything. We are not worried about inverse tangent. So far we know that we have 0 to positive infinity. This guy includes everything. So we need to find the intersection between them. The intersection between 0 to positive infinity and negative infinity to positive infinity is going to be the smaller set, is the smaller interval. 0 to positive infinity. What about the denominator? Now, denominator. For your denominator, you have x squared minus 1. X squared minus 1 cannot be 0, or x squared cannot be 1, or x cannot be plus minus 1. So we need to exclude plus minus 1 from this smaller interval as well. Again, recall the behavior of x squared minus 1. X squared minus 1 behaves like this. It passes x-axis at negative 1 and 1. We need to exclude these two from the domain. So the domain of the original function that we tried to discuss, let me move this a little bit up, ln of x plus inverse tangent of x divided by x squared minus 1 is 0 to 1 union 1 to positive infinity. Remember that we need to exclude negative 1 and 1, but negative 1 is not even in this domain to discuss, but we have to exclude 1 from this domain. So take a look. If you look at the horizontal line, here you have 0 to positive infinity. This is basically 0 to positive infinity, 0, and shaded to positive infinity. But this guy says, hey, you cannot take 1 as well. So we need to exclude 1 as well from this shaded region. So you have 0 to 1, open parenthesis, because we're using open circles, union with 1 to positive infinity. This is the domain of this function. You can visualize this, use interval, or you can write it in set format. You can say that, hey, The domain is the set of all x values such that x is larger than 0 and x is not 1. And the function is continuous on its domain. Is continuous on its domain.